Hey there, this is Math 7. We're looking at Unit 1, and your teachers here at Altair, we're giving a mid-unit quiz, and so this is a little bit of an extra practice about halfway through your Unit 1 on scale factors. So we have some problems here that are really kind of taken out of your book and just put back here as practice to help you prepare for your upcoming quiz that I think you guys have on Monday. Of course, coming up in a few weeks, we do have Into the Woods. The Bear Stage production of Into the Woods is going to be September 27th, 28th, 29th, and October 4, 5, 6. Come and check that out if you want to see a really cool show. Come watch the high school kids. All right, so first question is, which figures are scaled copies of the original F-shaped figure? And we're supposed to circle our answers. So to find out if it's a scale copy, there should be some relationship from the first shape to go into the next shape. So first of all, let's take a look at what we have originally. We have a length up here of 2 on this side, and then we have a 1, 2, 3, 4 on that one there, and we have a length here of 1. So my initial size for this F is a 2 and a 4 and a 1. And so when I look at the options here, I want to make sure that it is growing, what we would say perhaps proportionally. But to do that, remember that when we're going from a scale factor from either small to large, I'm going to multiply by some number. If I'm going from large to small, I'm going to multiply by a fraction. Or I can think of it as I'm going to divide, or I'm going to divide. But it's probably better to think about multiplying by a fraction to go there. Let's take a look. I'm going to start off, because we're reviewing here, I'm going to start off with drawing number 2 as a place just to begin with. Because when I look at drawing 2, I notice that it has 1, 2, 3, 4 across the top here. And I have 1, 2, 3, 4, 5, 6, 7, 8 down there. And I have 2. So what I need to ask myself is, to go from 2 to 4, is there a multiplicative factor that I can use to go from 2 to 4? So you're asking yourself, 2 times what number would give you 4? If you know your math facts, hope when we get some of those down, we would recognize that, well, it's times 2. That's what we're multiplying there. I want to then verify with the other numbers. So if it is going to be a times 2, then this should also be a times 2, 4 to 8. Well, is 4 times 2 equal to 8? Sure it is. And it'll also be true for here. 1 times 2 is also 2. So my scale factor for drawing number 2 is actually a times 2. It's increasing in size by a times 2 scale factor, and that happens for every one of the lengths there. If I look at drawing number 3 as my next one, I notice that I have 1, 2, 3, 4. This looks a lot like the scale factor going from the first one to drawing 2. That would be a times 2, right? No problem there. But to be a scaled copy, all the sides have to be scaled copies. All of them. Every single side. So we already know that if this is a 4 and I'm going to do times 2, I should have 8 right here. And when we take a look, we have 1, 2, 3, 4. That's still the same. That's not going to work. So it's not a scaled copy, because there's not a value we can multiply this, this, and this by to end up with a 4, 4, and in this case a 3. That doesn't make any sense. This is multiplied by 2, that's multiplied by 3, and that's multiplied by 1. To get those numbers. And that's not the same scale factor used on each length, so we would say no, it is not a scaled copy. So I go back to my directions, it did say circle, so we're going to circle that as a scaled copy. This one we could kind of cross off and say nope, not going to work. I saved this one for the end because it's a little bit different. If you look at it, we notice that we have a value of 3 up here on the top, and then down the length we have 1, 2, 3, 4, 5, 6. And I have a length here of, I'm not quite sure. It looks like maybe 1.5. So I'm gonna write down 1.5. Not sure exactly, but that's about what it looks like. So what I have to ask myself is, how can I get from 2 to 3? Now again, because I'm increasing, I know I'm going to multiply. So the question I'm really asking is, 2 times what number can get me to 3? At this point, you might stop and think, well, I'm not really sure. To get from 2 to 3, it's not 2 times 1 because that's 2. It's not 2 times 2 because that's going to be 4. So if 2 times 1, oops, sorry about that. If 2 times 1 equals 2, and 2 times 2 equals 4, and I want to get to 3, I know that whatever I'm multiplying by needs to be somewhere between a 1 and a 2. That's just what I know in my head as I'm thinking about it. But I also know a little bit about fractions. I know that when I multiply a number by a fraction, I can have things reduce. What I mean by that is this. What if this number was a fraction? Which we know we can use a fraction, not a problem. So I'm going to divide right here a number by 2. Now the reason I'm choosing 2 is that 2 times a number over 2, this will reduce. 2 over 2 reduces to 1. Knowing that that's going to reduce and essentially become a value of 1, I need to put a number here that will equal that number there. And in this case, because I want to get a 3, I would say 3 over 2. So 3 over 2, when I multiply that together, 2 times 3 is 6. 6 divided by 2 is 3. Seems to work. My scale factor, it would appear, would be 3 over 2. But let's confirm that. So I know that to go from 2 to 3, I can make work by 3 over 2. What happens to the 4? Well, if I multiply 4 times 3 over 2, let's do this together. 4 times 3 is 12. I still have it over 2. Whoops. My brain's skipping ahead of me a little bit. 12 over 2. And 12 divided by 2, or a fraction 12 over 2, can be reduced to 6. Does that match there? It sure does. So I can get from 4 to 6 by multiplying by a scale factor of 3 over 2. Now 3 over 2, if you want to think might take one more step, I can write this as a mixed number because there's 1 2 inside of there, and 3 minus 2 is 1, so I have what's left is 1.5. Think back to where we started. What did we say? This number was going to be somewhere between 1 and 2, and sure enough, it's 1.5. So this one, even though it might look slightly different, is also a scaled copy. So 1s and 2s are scaled copies. And so we use multiplication to solve for the middle one. We also use multiplication using a fraction to solve for that one. And we found that when we multiplied this one, nothing really quite worked out. Let's move on to the next one. The next set of questions says to use the 2 figures below to answer the following questions. Now this time we have 2 pictures, and this is from one of your homework sheets here if I'm not mistaken, or from the classwork. And we have 2 pictures here, and what we did is we removed some of the images and we put some lines here. So let's follow the directions and be careful here, because we see we have one is smaller than the other. So keep in mind, if I'm going to go from here to here in terms of a scale factor, my scale factor is going to be multiplied by some large number. If I go from this way to this way in terms of a scale factor, I'm going to multiply by a fraction. I'm going to write a half, but it's not a half, that just means a fraction. Alright, no problem. So that's what we're going to do. So if I was to think back over here, if I went from 2 to 4, my scale factor was, to go from 2 to 4, my scale factor was times 2. But if I was to go from 4 to 2, my scale factor would be times a half. I write the inverse of that number. Instead of 2, I flip it over and I have a half. I can also think of that again as divided by 2, but I think it's easier to take the scale factor and write down the inverse of the reciprocal of it. Instead of 2, you have 1 over 2. Alright, so that's great there in terms of what I'm going to do. Remember though, when we do this, do angles change? Do angles change? That'd be nope, they always stay the same. To be a congruent shape, the angles always stay the same. So let's look at our questions. What scale factor takes figure A to figure B? So we're going to go from A to B, so we know we're increasing. That means our answer should be greater than 1. It needs to be a pretty big number to be going up there. Okay? So how do I get from A to B? Well, let's take a look. I have 1.5 going to X. Well, that's not going to help me out because I don't know. Here I have matching numbers. So sometimes it's good to look at your matching numbers here. So this length is 2.5 and this length is 5. So I'm comparing the 2.5 to 5. So I have to ask myself, 2.5 times what number is going to get me to 5? And they have nice numbers to work with here because 2.5 times 2 actually does equal 5. Sometimes I think about it like money a little bit, right? If this was $2.50 and I had another $2.50, I'd end up with $5. There's my 5 there. So to get from 2.5 to 5, my scale factor going from A to B is times 2, or I can just write down it's 2. What scale factor takes figure B to A to go from here to there? Well, that's asking 5 times what number is going to get you to 2.5. And in this case, once again, we're going to say it's going to be 1/2. We're going to take the 2 and we're going to flip it over and say it's a half, right? So we flip it that way. Now I can look at some missing lengths here. What is the missing length? X in figure B, 1.5 to X. To do that, we're going to take our 1.5 and we're going to multiply by the scale factor of 2. That's my scale factor. And so we end up with 5 times 2 is 10, carry the 1. 2 times 1 is 2, plus 1 is 3. I have 1 decimal, so I put my 1 decimal, move it here to there. And my answer is going to be 3. So this value is 3. And finally, number 5, what is the missing angle measurement in X? A measurement X in figure A. So we're asking, what is this angle measurement? To figure out what that angle measurement is, because these are going to be congruent shapes and they're copies, all I have to do is find its corresponding part down there, and I look and see that it's 82 degrees, so my answer is just simply 82 degrees. I don't have to worry about scale factor. It's a corresponding part. It's just going to be a match. So be careful about that one too. Let's look at number 3. For number 3, we're going to have a picture here of a little triangle shape, and it says draw a scaled copy with a scale factor of 3. So that scale factor of 3 means I'm going to multiply all the lengths by 3. So to begin with, it's probably good to count up a couple things. I notice that I have 1, 2, 3 is my length there. So I have 3 as a length there. I know that this diagonal seems to go across one space there, and this diagonal seems to go kind of across two lines there. So at least I could start here with my vertical line 3, because a 3 times 3, because my scale factor is going to be 9. So I know from the very beginning that my height of this little triangle is going to be 9. So let's start from here and see how far we get. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way up to the top. So I begin by having this nice long line right there. That's my first line. For the next thing, I know I'm going 1, it's a square, so I'm going 1 across here. So 1 times 3 is going to be 3. So in this case, what we want to do is we want to extend this up 3. 1, 2, 3 to get to that point right there. So we're trying to make this match. And for our last line, we had a length of 2. It's a little tricky because it's not quite a straight line, but because it's a triangle, I could also just say, well, it's a triangle. I have my 2 sides that I know for sure, and let's connect our lines up here and see what we end up with. We end up looking like that. It certainly does look like a scaled copy. You could look at the length here and recognize that we're going, it's kind of the fun stuff here, is to go from this point to this point, we're going down 2 and over 1, right? Going down 2 over 1 to get from here to here. And then to get to this next point, it's down 2 and over 1 to there. And then over here, it's down 2 and over 1 to there. So if you take a look, just as an extra thing, how many times do we do that? 1, 2, 3. So it is indeed times 3 to get from there to there of that length, whatever that might be. Okay, so that's number 3. Let's look at the back side. Okay, it says answer questions 4 to 7 using this shape below. We have an original, we have a scaled copy. All right, with a scaled copy for our lengths, let's just recall, for our lengths we have to use the scale factor, which means we're going to multiply by something. Okay, multiply by something. It's going to be a number greater than 1 if we're going small to big. And we're going to multiply a number less than 1 if we're going big to small. So less than 1 means it's going to be some sort of a fractional component, most likely. So in this case, we have an original is small, and we're going to larger, which means we're going to multiply by a number greater than 1 to get from here to here. So let's find some corresponding parts. It sometimes helps if you just color them so you can see. So this line right here, we'll make that the red one, and we'll make that the red one right there. We'll go ahead and make a green line right here on this length. So green, I'm going to correspond to this one, that's green. And then I can have this guy right here, that's peach, and peach there. Just so we know what we're talking about. So let's take a look at, first of all, it says, what is the measurement of angle W? Well, angles, we said that angles stay the same. If it's going to be a scale copy, the angles stay the same. So I need to find W. W is located right here at the tip of the triangle, which means it's going to correspond to the tip of this triangle. When we look at that triangle, it says 42. So we write down 42 degrees. Number 5. What is the measurement of angle X? Angle X is right here. It's right here in this space. That's our angle X. And it's going to correspond to this one right here, which it says is 78 degrees. What is the length of side Y? Y is here, and this guy is here. Well, I don't know what the scale factor is. To do this, I have to know the scale factor first. So to find the scale factor, I need to find two lines where I have the corresponding lines and I have lengths, which I happen to have right here. I can see that I have on the red line a value of 6, and over here a value of 18. So I have to ask myself, 6 times what number is going to get me to an 18? Because if you think about your 6 math facts, you have 6 times 1, 6 times 1 is 6, 6 times 2 is 12, and 6 times 3 is 18. So for my scale factor is going to be times 3. That's my scale factor that I'm playing with here. But let's remember, if I'm going small to big, I'm going to do times 3. What if I'm going from the big one to the small one? If I'm going to go from the big one to the small one, then I take my 3, and instead of multiplying by 3, I'm going to multiply by the reciprocal. I'm going to multiply by 1 over 3. Okay? Or divide by 3. Depends on how you want to look at that. So for number 6, when it says what's the length of Y, we're asking, how do I go from 27 to the smaller copy? I'm not going to multiply by 3. I'm going to multiply by something less than 1, which is 1/3. So it's really 27 times 1/3. Well, 27 times 1/3 can be written as 27 over 3, or 27 divided by 3. And again, back to your math facts, 27 divided by 3, well, 3 times 9 does equal 27. So the length of Y would be 9. And again, that's just because Y, 9 times 3 equals 27, and that's my check. And I just go back the other way, 27 divided by 3. And then looking at our last one here, for this one, 27, what's the length of side Z? So here's side Z. We have our original is 7, and we're going to Z. And we know going from small to large, we just multiply by the scale factor, which is 3. So 7 times 3 is 21, and that's where we stop right there. So that's the idea. So we had a couple angles. Just remember that they don't change. And then we went from big to small, so we multiplied by a number less than 1. And then we went small to larger, multiplied by a number bigger than 1. Let's look at number 8. It says to select all the ratios that are equivalent to 20 to 5. 20 to 5. All right, so this is a little bit interesting because what you're looking at is you take a number like 20 to 5, and we could write it this way, or you could write it almost as a fraction if you wanted to. I like to write it down as a fraction to begin with, 20 over 5, or almost like two, like a double number line, but we'll get there later. When I think about 20 over 5, I know I have 4 5s inside of 20, because 5 plus 5 plus 5 plus 5 is equal to 20, right? And I have 1 5 on the bottom. So in terms of reducing this really becomes 5 goes in there 4 times, and there's 1 5 in there. So in terms of just reducing 20/5, 20/5 can be reduced to 4 over 1. Okay? So now think of it this way. I could think about my factors of 4. I have 4, I have 8, I have 12, 16, 20, 24. Those are all good factors of 4, starting at 4. And it's 4 times 1, 4 times 2, 4 times 3, 4 times 4, 4 times 5, and 4 times 6 that allows me to get there. So I've just created 6 more ratios that are all equivalent to 20/5. Now let's take a look here. It says select all that are equivalent. I have 12/3. If I look over here, here is 12/3. So that's going to work. Letter B, 4/1. Here's 4/1. There it is. That's going to work. This one says 3/12. Order is very important here. I don't have a 3. I know that I have a 3/12 there, but this one is backwards, right? So it's not going to work. That would be if this was 5/20, we would say yes. But that's backwards, so we would definitely say no. When I look over here, I have 24/6. Well, there's 24/6. That's going to work as well. And finally, we have 10/2. What we're seeing happening is like, how do you get there? Well, 20 to 10 is divided by 2. But what's 5 divided by 2? It's not 2. It's 2.5. So we would say no to that one as well. So that's one other way you could look at doing that problem, or a problem like that, decide if it is equivalent. Another way you could do is you could always set it up like this. You could say it's 20/5, and you can make it equal to one of these other ratios. Let's just take, for example, B for now, and say it's equal to 4/1. If that is true, and this is something you might have learned in 6th grade, I'm not sure, you can cross multiply, and 5 times 4 is 20, and then we check this way, 20 times 1 is 20. And if they're equal or equivalent, we would say, yep, it's going to work. And that works for A and D as well. Number 9. Jesse made a figure with an area of 10 square units. So they make some kind of shape, and the shape has an area of 10 square units. Great. Johnny made a scale copy of the figure, had an area of 40 square units. 40. Alright, so we know we're going from a smaller object to a larger object. It says, what scale factor did Johnny use to create his scale copy? Because we're going from small to large, we know we're multiplying by a number greater than 1. So multiplying by a number greater than 1. But when we're looking at area, area is a little different. When we did a shape and we just found like the length, right? If I had a length of 2, and I had a copy over here of 6, we said, well, to go from 2 to 6 is simply times 3. That's just how it's going to work there. No problem. We got that. Great. But when you talk about area, area changes things a little bit. So with area, what happens is we're going to take our original and we want to multiply it by the scale factor squared to get our copied area. Okay, so we take the original area, we multiply it by the scale factor squared, and that becomes our copied area. So with Jesse and Johnny, the original area was 10, and they multiplied by a scale factor squared, which we don't know what that is, to come up with 40. That's the setup for what's happening there. If it was going big to small, it would be the same idea, except we would be, again, having a scale factor that's probably going to be less than 1. But for now, let's get the scale factor by itself. To do that, I divide both sides by 10, And so I have scale factor by itself, scale factor squared on one side, equal to 40 divided by 10 is 4. And this is where you have to use a little bit of mental math. It's probably the easiest way for now to think about what two numbers can you multiply together to end up with 4. So 1 times 1 is 1, 2 times 2 is 4. Probably where I want to stop. So 2 squared equals 4. Well, this value of 2 represents our scale factor. So the scale factor in this case, our scale factor equals 2. And that's the scale factor that Johnny used to get from this to his model there. Let's look at one last one. It says if 1 inch represents 3 meters in the image of the stop sign, what is the actual height of the stop sign? So if I take my ruler out and I measure this stop sign, I notice that it is about 3 inches. That's how tall the stop sign is. So in terms of my scale factor, 1 inch represents 3 meters, right? So to get from the 1 to the 3, I am multiplying by 3. In this case here, I had 3 inches. And so I'm going to multiply that by my scale factor of 3 to come up with 9. And this is not 9 inches, but instead 9 meters. And that's what we do for number 10. These are the same types of questions you're going to see on your quiz coming up. So make sure you practice these, study them. If you have questions, be sure to ask your teacher. Good luck and have a great day.